everyone, this is another episode of Tech Break by Friday. Where does the term Agentic AI comes from? What are AI agents and why we use them instead of foundation models? So, the term Agentic AI is actually really old. It comes from psychology. Psychologist Albert Bandura introduced the concept of agency. Agency in individuals is described as the ability to act in full or partial autonomy. So, AI agents are AI systems that can perform a certain amount of tasks autonomously. So, let's discuss how an AI agent system can solve problems. First step is perceive. So, this system gathers information from its environment. In this stage, the system will try to find key elements in the data that depict categories or determine any relevance between the data. Let's say that this is some sort of way of gathering more information about what it's out there and how it can impact it. So, step 2, reasoning. An LLM acts as an operator or a reasoning engine inside the agent. So, it understands the tasks given, it allows tools, and it utilizes them to come up with results to reach out to a final solution. One of the use cases is that you can also use RAG to determine the way we would solve a specific type of problem from the RAG data that we currently have. Step 3, act. So an agent can make decisions that takes appropriate actions. By integrated, custom implemented or external tools, agents can act with them, they can get a result from them, and then they can decide how to solve the specific problem. If the agent receives a prompt or some sort of instruction in a form of a template in order how to solve a specific problem, then it will act on these instructions. This removes some sort of manual work that humans might have done before. For example, in case of getting some Excel data and creating an email for some sort of colleagues with companies' internal data that you want to share with your colleagues, then you could create some agentic workflow there and you could have written the email. You should always test the AI results. Fourth step is learning. Usually there is also a feedback loop. This is like some sort of a flying wheel. So basically a flying wheel in a system is something that basically improves itself. So you increase the intensity in one of the elements and the flywheel basically makes the whole system better. And that allows the agent to improve on the tasks on hand for next time. And since he gets that feedback, that could also be since the data from the agent's previous iterations are then being fed into the agent, and then the system can enhance the whole agent. This is a powerful solution for businesses, and they can drive faster decision making and operate their businesses more efficiently for sure. So let's walk through some analogy. As humans, we use short-term and long-term memory to remember things easier. So short memory helps us remember the context of a conversation with another human, for example. In agents, the short-term memory can be used to keep the context of the conversation in the same thread, like customer service bots do. AI agents remember the information that you have provided in the conversation previously. For example, we mentioned before the customer service agents. When you open up a new tab, they remember all the previous information that you have given them, so they reply to you based on the context that you have provided. In case of long-term memory, a direct equivalent could be RAG. So we have a vector database that contains documents transformed to vectors. The agent has access to its data store to use at all times, and they can act upon that knowledge. So it's some sort of like how we have our long-term memory, that's all the information that we have learn through our lives and we can actually use them. But the thing is that RAG is not updated through learning most of the time. You currently have to update it manually most of the times, until this point, at least. So AI agents can act autonomously, but they need an LLM as their main component. So the question that we had in the beginning was why we use AI agents instead of the foundation models. So instead of training an LLM and fine-tuning it at all times, we might want to use extra tools. And this agent architecture allows us to do so, and we gain high benefits from it. So their ability to reason depends on the large language model that we have chosen. So if this large language model is really good at a specific task and we use the agent for this specific task, then we see some sort of improvement there. Their ability to solve problems is simulated from how we humans observe, perceive the world, reflect on what we have seen, and we decide to actually do a certain action, and then we solve the problem. In case of success, as humans, we learn how to solve the problems, and in case of failures, we learn that we wouldn't do this certain action in order to solve the problem, and we should actually try something else. We can also allow our agent to try multiple things until it comes up with a solution. So, I think we came up to a really good understanding of how AI agents work. So if you like this episode and you think that it's some sort of useful to you, hit the like button. And if you want to get more updates, please subscribe, and see you later.